In this video, we're gonna learn about more of identities. So you will have more identities to memorize. And we're gonna start with our Pythagorean identity. This is the first one that students usually learn. Sine squared t plus cosine squared t equals 1. We already learned this identity. So now what we're going to do, we're going to divide both sides of this equation by cosine squared t. So cosine squared t and the cosine squared t. What happens here, this fraction, it splits. We can rewrite it as sine squared t over cosine squared t plus cosine squared t cosine squared t. So like reverse addition of the fractions. So if we would be adding these two fractions, that's what we would get. But we're going actually in the opposite direction here. And what ends up happening is that every term that was there before gets to be divided by cosine squared t. In the future, I'm going to just skip this step and go straight to this step so we understand what's happening. Okay, so what's sine squared t divided by cosine squared t? Well, this is sine of t over cosine of t squared. And this cosine squared t divided by cosine squared t just becomes a 1. And 1 over cosine squared t is just 1 over cosine t squared. All right, so what is this? Do you recognize this? Sine t over cosine t, this is tangent. And we're going to say it's, but because it's squared, it's going to be tangent squared t plus 1. And what is this? Do you recognize 1 over cosine t? I hope you're saying right now that it is a secant t. So it's going to be secant squared because of that square. So here's your next Pythagorean identity. All right, and now we're going to do the same thing to the original Pythagorean identity, but only instead of dividing by cosine squared t, we're going to divide it by sine squared t. Let's see what happens. So again, we start with sine squared t plus cosine squared t equals 1, and we're going to divide each term by sine squared t. So this simplifies into a 1. Now cosine square over sine square, this is going to be your cotangent squared. And 1 over sine t squared. Right, so we have 1 plus cotangent squared. 1 over sine is cosecant, so equals cosecant squared t. All right, so this is another derivative of your Pythagorean identity. So these are called alternate forms of Pythagorean identity. So this is the original, and these are the alternate forms. Again, worth to remember. So now, how do we use these identities? So for example, we have a secant t equals negative 17 over 8, and our angle is between 0 and pi. Okay, so I can start with any of the identities that involve the secant and another trig function to find the trig function. So I could actually recall that secant is 1 over cosine and find the cosine first. But just for the sake of it, let's find the tangent using secant. So we have tangent squared t plus 1 equals secant squared, which is negative 17 over 8 squared. Tangent squared t plus 1 is, what's the 17 squared? Is 289. And 8 squared is 64. Okay, now I'm gonna subtract 1, but here 1 turns into 64 over 64. That's still a 1, right? I hope you remember that. So tangent squared t, I don't know why I'm writing it in red, equals 225 over 64. So for the tangent t, it's going to be, we're going to unsquare. So it's either positive or negative square root of 225 over 64. Which becomes positive or negative root of 225 over root of 64. And root 25 is 15 over 8. So this is my tangent. Now I have to choose between the positive 15 over 8 and the negative 15 over 8. So what's going to help me is the knowledge that my angle is between 0 and pi. So it's either in the first quadrant or second quadrant. Well, since my secant is negative, and in the first quadrant everything is positive, all trig functions are positive, so I know that it's not in the first quadrant, it must be in the second quadrant. And what's the value of tangent in the second quadrant? I hope you're saying that it is negative. So that I go with tangent of t equals negative 15 over 8. All right. In order to proceed, I still have to find my sine and cosine. So I'm going to use the secant. And recall that cosine t is 1 over secant t. So cosine t is 1 divided by negative 17 over 8. Okay, so I know my cosine. Now I can use Pythagorean identity to find the sine, because sine squared t plus cosine squared t is 1. That gives me right? And 17 squared is 289 equals 1. So sine squared t is 1 minus 64 over 289. And I'm going to rewrite 1 as 289 over 289 minus 64. I got 225 again over 289. So, okay, so sine squared is 225 over 289. Now, I need to unsquare it. Again, when you're unsquaring, you don't know if it's gonna be, it could be a positive or negative. 15 over 17. But again, the knowledge that our t is located in a second quadrant gives us assurance that it is positive. So sine t is positive 15 over 17. Did I say the second quadrant? That's what I meant. Okay, so far we know tangent t, we know sine t, and we were given secant. So we know 3 trig functions. So in the process, no, we also found the cosine. So we already know 1, 2, 3, 4 functions. And since we know sine, we could find the cosecant, which would be 1 divided by sine, so 1 divided by 15 over 17. So it's 17 over 15. So that's our next one. Oh, guys, you don't see it. Here it is. And our last function that we need to find is the cotangent of t. But the cotangent is 1 divided by tangent. So it's 1 divided by whatever we found for the tangent. We found negative 15 over 8. So that's going to be 1 times negative 8 over 15, which is negative 8 over 15. And we're done. We found all 3 functions. So yeah, the cotangent equals negative 8 over 15. So now I want you to try using trigonometric identities to find the values of this angle. And says the cosine t is 12 over 13, and t is in quadrant 4. So we have a picture here. This is our t is in quadrant 4, and 12 over 13 is the x-coordinate of the point on the circumference of a unit circle. Go ahead, pause here, and solve this problem. And this is it for this video. I'm gonna show you more examples in the next one.